Hello everyone, my name is Samsul. I'm from SUSE APJ team. So today in this session, I'm going to talk about SAP HANA Scale-Out with high-availability NFS using DRBD. So the session code will be HOL-1064. Okay, on this demo labs, what I put. So I divide this in 3 different chapters. So first, we're going to do the DRBD configuration. What is DRBD? This replication block device. Then the second one, we're going to create the DRBD into the HA cluster. So with the HA cluster, we're going to use DRBD as a this for the NFS service that we're going to serve. Okay, so why we're going to use NFS service? So NFS service is required to be used for the SAP HANA Scale-Out configuration. So we can use the most cost optimized which is using NFS, or you can using any other like concurrent file system or GPFS or etc. Okay, so after that, for SAP HANA Scale-Out installation, I'm going to configure 2 nodes. One node that will become act as a master and also a worker node, and another one that will act as a standby node. Okay, this is the VM configuration that I prepare for this demo. So I put 2 virtual CPU for each node. Then I enable the CPU host configuration. So if you're able to deploy this VM in your environment, make sure you have to click this enable CPU host configuration, because it will take some of the configuration from your physical BIOS level for the KVM host. Then the third one, the memory allocation, I put 16 gig RAM because that is currently the limitation of my physical machine. If you have a more RAM, you can just bring up to 32 gig RAM, or maybe minimum is 24 gigabyte RAM. Okay, in the operating system, I already pre-installed the operating system here. I'm using SLES 12. So I put the host name is HOPDB HA1 with the IP 10.325.121, then HOPDB HA2 with the IP 10.325.122. So each login, it will be the root user, then the password will be Linux. Okay, and both of the node has the SSH key exchange already. I using the command SSH copy ID, so you can access both node without any password. So this is also a requirement for the SUSE HA later. Okay, now we talk about the DRBD and also the in NFS high availability. So the first task that we're going to configure is we're going to configure the DRBD disk. So after we configure the DRBD disk, we're going to set up a cluster. This will be on the second task. Then inside the cluster, we're going to add more resource. So the resource will be the DRBD resource, the multi-set DRBD resource, the NFS server resource, and then the virtual IP. So on the second task, we're going to make sure we're already running DRBD with NFS. So then we can use this for the SAP HANA binary later for our scale-out configuration. Okay, then later on the final task, we're going to develop the SAP HANA scale-out using the SAP HANA Fiber Channel Storage connector. So the shared disk is coming from the iSCSI server. Then we're going to have a 2 node, one as a master and also a worker, and another one as the standby. So the master will be HOPDB HA1, then the standby will be HOPDB HA2. Okay, so then later if you want to add more for the higher availability for the SAP HANA Scale-Out, you need to add additional nodes. So minimum should have at least 3 nodes. So you're going to have 2 master and worker, and 1 is standby node. So if one of the master or worker down, the standby node can take over, so you doesn't have any downtime on your HANA database. Okay, so that's for the some presentation that I prepare. Now we go for the configuration. Okay, so as you can see here, I already access HOPDB HA1 and HOPDB HA2. So now I do IB ADM. So both node, I have to make sure there's nothing service. DRBD ADM down R0. DRBD ADM down R0. So because previously I put this resource as the name R0, so DRBD ADM status. So no configuration is found. So that is correct. So now we're going to configure our first DRBD. The DRBD I'm going to use is using this file, lv DRBD DRBD VG. Okay. So as the same as this one, lv DRBD DRBD VG, 20 gigs each. So first, you can execute to initiate the config file from YAS, or you can, I have the configuration ready here. So this is my configuration. So make sure it's the same configuration for the second node also. Copy, paste. All right, as you can see here, it's the same configuration. Make sure the IP is correct. The port is 7788, 7788. So this will be the logical block device DRBD. I call it def DRBD 0. So this is the physical block device using the DRBD VG and also the LV DRBD. So both have the same configuration. Okay, now we're going to set up the first DRBD. So the command is DRBD ADM create MD R0. So this is the first we're going to initialize it. So you're going to initialize it, put the metadata inside it, then we just enable it. So the same thing as the DRBD ADM create MD R0 for the second node. Yes. All right. So now has been initialized. Now we're going to double confirm. We're going to down R0, then up R0. So make sure our this one also down R0, up R0. Now we have to check the status. Okay, so the status is correct. So now no one is primary or secondary. Yes, so both is now is a secondary. There's no primary, so that's why the disk is inconsistent. So before that, we need to create primary and secondary. So if you create the primary and secondary now, you're going to do the replication and sync whatever is listed on the data in primary and replicate to the secondary. So I want to skip it because I know that this have nothing inside. So I'm going to skip it. I can run on the first one. So this is only on the first node, the DRBD ADM, new current UUID, clear bitmap R0/0. So with this, whenever I promote as primary, then it doesn't need to replicate because it will totally become empty. Okay. Now I up it as primary, DRBD ADM primary force R0. Okay. So now I check it at primary. So I clear. Then this one also I clear. Then you check the DBDM status. So it's primary. Secondary is HOPDB HA2. So it's up to date. You don't need to do the synchronization anymore. Everything will be empty and it will be up to date. So also this will be the same thing. So primary is HOPDB HA1 and this is a secondary. So now we're going to test it. So if you have this -L grep -I DRBD, you can see that this DRBD disk is available now. The logical replication disk is available now. It's only appear on the master. So if you get it from the secondary one, you cannot see it, DRBD. So nothing. This is only the block device. Okay. So it's only applicable to the master. Now you can you can format it to the SFS format because later you're going to put it on the NFS share. So it have to be on the NFS format, SFS format, DRBD 0 -F. So F we're going to force it. So later now we're going to format it to the SFS file system. Okay, so after you format it, so just to test it, we try to mount. Okay, now your disk can be mounted. So this is correct. Okay, so it's only can be mounted on the primary node. So I have to mount it there, because later we're going to let the cluster to do the mounting for us. Okay, so df -h, so then clear df -h, then DRBD status, secondary DRBD status. As a primary. So in our first task, our DRBD configuration has been successfully configured. So in the second task, I'm going to do the integration with the HA and also the NFS service. Okay, see you on the second task. Hi, so we are now going for the second task, which are we going to do the SUSE HA cluster. Then we're going to integrate our previous DRBD configuration with our NFS service. Okay, so before we going to do the resource configuration and everything, we're going to make sure our cluster is ready. So here we're going to show you how to create the SUSE cluster. Okay. So before we start, we have to make sure some of the prereq has been ready. So now, as you can see, we are running on VMware, not on VMware, on KVM, on a VM machine actually. So we doesn't have a watchdog. So in a VM environment, you need to have at least a soft dog for the cluster to be working. So just check on the kernel module is the soft dog is available. So soft dog is available. Then go for the second one. So soft dog is already available. So mean your software dog is available. Now we're going to start with a configuration. So we're going to do it from the first node only. So we're going to run SLES HA init. So this is on to be run on the first node, which is SLES HA init. Okay, so we take some time to verify. So first, it will check our SSH key. So we already do the SSH key exchange earlier, so we don't need to override this. So on the first one, I'm going to select no. Then it will check for the chorusing. Chorusing is the cluster messaging service. So what are the network that we're going to configure our cluster? So I'm going to use this network 10.325.0. Then the multicast, leave it default as a unique one. Then the port as a default one. So do I need to override the authentication? No. Okay, now we're going to configure the SBD. SBD need to be a shared storage. So I already configure a shared storage for this. I create a 1 GB disk for this shared storage. So you can you put a dev SDB or SDA or SDC, but that one can be the naming can be changed. Maybe if you add new disk or we remove a disk, we might change. So that's why we use the persistent, or you can use you can get by ID or you can go by dev mapper. So which one is more feasible? So here I'm going to get my SDB. So I put a 1 gig device. So it should be this 1 gig SDB. But I'm not going to use this naming convention. I'm going to use the device mapper. So this will be the device mapper name. Okay, so this name will not be changed even though you change the disk layout, you take out the disk, you insert new disk, this one will always be permanent. Then I put here. Oh, sorry. Have to select yes first. Then only I put the part to the storage. So wipe it the data inside. Okay, now we wait until the system initialize the SBD. As you can see now, after that, it's going to start the hot cluster interface or the hot cluster wizard. So you can see this is the IP address. Then the cluster is HA cluster. then the password is Linux. So now it's going to wait for the cluster to be configured. Okay, so the cluster has been configured. Then then there's a question if you want to configure the admin IP address. So this admin IP, how you going to manage the cluster. So without this admin IP, if you want to manage the cluster, you can go directly to each of the node. Maybe go to the HOPDB HA1, or you can go to the HOPDB HA2. But if you give an IP address to it, you just go to the single IP address. Then it will go into either one, HOPDB HA1 or HOPDB HA2. So for this one, I'm not going to do it. So I'm just going to say no. Then it's done. So how to check it? So I run CRM mon minus AV. As you can see, there's a one node cluster and one resource configure. So it's only one online. Then one resource is the SBD. So later I'm going to add the second node. Okay, so now we already set up our cluster with a single node, which is HOPDB HA1. So as you can see here, there's a one node configure and one resource configure, which is the SBD device. So now we're going to add the HOPDB HA2 to join the first node. So the command is SLES HA join. So it's very easy. Just enter. Then you have to put the IP of the first node, 121. So no need to override the SSH key for the nodes because you already pre-configure it. Now later you can see that you have it will detect the new node. So you can see a HOPDB HA2 on this cluster after they have finished the configuration. Now it's still probing the new partition, waiting for cluster to be up for the second node. As you can see, now it's detect. It's now reload. As you can see, I have two node configure and two online nodes HOPDB HA1. Okay, so the second second node has been configured into the cluster. All right. Okay, now our cluster is ready. So what's the first thing? We need to add the resource for our DRBD and NFS server. So before that, let's check the cluster configuration. So it's HA cluster and Linux. As you can see here, you can see one resource here is tonic and with two nodes. So there's no other resource is available here. Okay. So now we're going to create the resource one by one. Okay, so I leave it the first one there. I'm going to add the resource from here. CRM configure CRM only. Then we check configure. Right. So the first thing, because if you can check the PDF guide, I already put the resource available for you. Or so it's the same that I paste here. So what the first thing we're going to do, we're going to create a DRBD resource. And first, just have to add this command. Okay. Then we add the second parameter. Then the third parameter. So this is a multi-step resource for DRBD, master and slave. Okay, so that's one resource available here. So I didn't commit yet, so the resource is not available there yet. Okay. Okay. Now the second one, I'm going to add the file system for the DRBD. So I'm going to add here file system for DRBD. Then what's the export part? So this is for the where to be mounted. So it will take the block device def DRBD 0 and it will mount to HANA exports. Then the target should be started. It will always need to be started. Then interval 60 seconds to monitor. Second. Stop and monitor interval should be the same. Alright, so that is the file system for our DRBD. Now we go for the third resource, which is the NFS server. So we're going to run the NFS server in both system, the HOPDB HA1 and also HOPDB HA2. Alright, so it will be alright, so it's done. Now we're going to create a virtual IP for this NFS. So I'm going to create one virtual IP, which is the IP address 10.3.25.100. Then the monitor is 10 and 20 seconds. All right, so that's it. We already put the primitive NFS server. Then we already put the virtual IP. Now we have to configure the group and the order. So first, we're going to create a group of NFS. So this group of NFS consists of the DRBD file system and also the virtual IP for the NFS. So before this group to be up, you need to have the IP and also the file system available. Okay. Then after that, then we're going to create a multi-state of the DRBD. So multi-state DRBD resource. So you're going to create a DRBD resource for the multi and slave. So this should be the one. Okay. Okay. Then after that, we're going to click the clone for the NFS server. So we're going to make sure the NFS server is running in both nodes. Okay. All right. Then for the few one, we're going to have a collocation. So this is important. So collocation mean what? The NFS need to be on the DRBD disk. So whenever the device has a master, the promoted one, it will always tie to the group NFS. Okay, it will not take the slave one. It will always go for the master. Then the order. So how the order to bring up the cluster? So the order is the DRBDs must need to be start first before the NFS start. So the multi-state DRBD promoted start, then only NFS able to start. All right, so there's nothing more. If nothing more, we can just commit. Then after we commit, we can see here. It will start starting up the resource. So now we can see we have a resource group NFS, we have resource group DRBD. So the master is HOPDB HA1, slave HOPDB H2. So the DRBD file system now start on the HOPDB HA1. The virtual and IP also HOPDB HA1. Okay. Then NFS server is start in both server. All right. So now you can see we have NFS running from this virtual IP. So we can try and exit. Okay, we just run the command show mount -e 10.3.25.100. As you can see here, is the NFS has been mounted. Okay, so what are the next? So we need to double confirm the NFS is start on the HOPDB HO1. So I'm going to exit this one and do F-H. As you can see here, the HANA export is from the DRBD 01. Okay, then if I clear here df minus h, so there's no DRBD on the HOPDB HA2. Okay, now we are going to need the NFS NFS mount point. We need to add for the HANA binary. So we have to add this vi etc fs step. We have to include this command. So we're going to export HANA export into the HANA Shared. So this is for the next installation for our HANA. It is required. So we have to enable this mount point. Oops, sorry. vi etc fs step. So okay, then I save it. Then I run command mount minus a, and then mount minus a. As you can see, df minus h. There should be a HANA Shared available from that NFS mount point. Then this one also should have NFS HANA Shared come from the same mount point. So this one we will use for the binary installation for our next task for the HANA Scale-Out. So, okay, then if you want to check on the GUI, as you can see now, everything is ready and fine. All green mean our resource has been done correctly. Okay, so I see you on the next chapter. Thank you. Hi, so we meet again for the chapter 3. So we already done on chapter 1 and chapter 2. Chapter 1 where we configure our DRBD configuration. On chapter 2, what we did, we do the integration, the NFS HA using the DRBD disk. Okay, so for the chapter 3, we're going to continue to do the HANA Scale-Out installation. So before we proceed, we just have to make sure everything is ready, that our HANA Shared folder has been mounted in both of the system. Then we check our cluster configuration and our disk configuration. Okay, let's go. First, I'm going to show our cluster configuration. So I'm just going to open the hot wizard. Then we go HA cluster, Linux. Okay, as you can see here, everything is ready. So our DRBD has been configured. Then our NFS also has been configured. So it's running. So now actually it's running on HOPDB HA2 as the primary NFS. Okay. So this is the detail. If you want to see, everything is green, mean everything is working fine. Okay. The next step, we want to make sure we already mounted the NFS HA. So this is our NFS HANA Shared df minus h. Okay, HANA Shared both has been mounted. So this will be our binary installation will be installed to this HANA Shared. Okay, the next step we have to check on our storage HANA FC configuration. So it's inside the cat HANA Shared global ini. Okay, so here we're going to have one master worker and another one is standby node. So we have to put this SCSI disk or this shared disk. So this is the worldwide ID. So make sure you put the correct worldwide ID so it can connect to the HANA Scale-Out. So when you see everything here is ready, we can proceed with the installation. Okay, I'm going to install the worker on HANA 1, then the standby on the HANA 2. So we go for the installation. We go to the OPT, HANA Shared, HANA Update, HDB server. Okay, so we're going to install from number 1. So then we're going to execute HDB LCM. Okay, GUI. Okay, we're going to using the GUI. Okay, first we have to define the storage config. Storage underscore CFG equal to HANA Shared. Then for this one, it's just for my lab environment. I doesn't have enough memory. I'm going to install it without memory verification. So ignore, check, min, mem. Then we run it. Okay, this will be the latest HANA. It's HANA version 2 SPS 04. So in here, we just go next, install new system, next, install SAP HANA database client, next, we put multiple hosts. Okay, then we put the password for the root user, Linux. HANA Shared, this is our NFS Shared directory. Host name, we're going to add HOL-1064 HA2. So the destination is a standby. The rest we just put the default. Then we go next. Wait until some verification happen before we proceed. Alright. So now the local host name is where we are local now is HOPDB HA1. So now we put nbm 0 here, which put to test. You can do this all using the command line. Rather than you put HDB LCM GUI, you can follow the guide, then you put HDB LCM only. Okay, HANA data, HANA log MB, leave it. So you have to measure two certificates here, the worker and also the standby node. Then we put password A capital BCD 1234, A capital BCD 1234. The next. So for the HANA DB password also we do the same password A capital BCD 1234. Okay, just make sure, just go through the summary, make sure everything is correct. So you can supposed to see additional host here, which is on standby. Then you can get the log in the var-temp directory. Then we go for the installation. Okay, installation will take a while. It will take around 20 to 30 minutes because you're going to install it through the NFS folder. So it's a bit slow rather than when you write to the local disk. So it will take around 20-30 minutes. Then I'm just going to leave it to be installed first. Then we come back after the installation is done. Okay, just as an add-on. So as you can see, we are still installing. I want to show what actually running in the background, so you can get all this log or how the installation is happen in this slash var-temp. So I'm just going to go for the the first DB HOPDB HA1. Okay, then we go to CD var-temp. Now we sort it to the latest where is the one running. So this is our installation GUI session. So there's another log where it's running HDB install. So we just copy this one and then do a tail. This is how you see what is actually running at the background. So in here, it show you to install package Python runtime. So you can just double confirm here. So it's actually extracting all the Python library to the system. So this is you want to know the progress at least because it's nothing show on the GUI unless the parent one which is running the extracting the Python runtime. So this is actually what is running on the background. Okay, so you can monitor this until we finish the installation. All right. Hi. So we already completed the installation. As you can see here, everything is done. All the installation has been done. So now we already running our SAP HANA database on a scale-out version. Okay, so we just complete this installation. Press. Okay, now we want to make sure that our installation has been done. So we can change to the HANA ID, the nbm adm. Okay, okay. So let me clear this setting. Now I want to see HDB version. Okay, so we are running HANA 2 SPS04. Okay, then we go for ESE, Python. So Python system overview. As you can see here, we have two hosts, distributed HANA. Then we are running HANA 2 SPS04, running on /12 SP4. So we have 25 gig of memory. Sorry, 30 gig of memory. Okay, because we have both of the system is running currently. Now we check HDB info. Make sure the services is running. Yes, it's running. Then we go check the landscape. Python landscape host configuration. So here we can see we have the HOPDB HA1, HOPDB HA2. So the one is also a master and also a worker, and the HOPDB HA2 is a master. It's not a master, it's a slave, and it's a standby by default. So we have one primary which become master and also worker, then another one as the standby. Then that's all. Or if you want to check the using the subcontrol, this is the host address 00 minus function get process list. Okay, everything is running, everything is green. So that's how our HANA. So we already configure our DRBD for our NFS. Then we already configure our NFS cluster on the second stage. Then the third stage, we're using the high-availability NFS. Then we configure our storage, which is our shared storage. We're running as SCSI here. Then we configure our HANA Scale-Out version. So by right, everything is running properly. That's that now you are running HANA high availability using NFS for the HANA binary. Then for the HANA database itself, we're running HANA Scale-Out version where we have a master and worker and another node as a standby node. Okay, so that's all for this session for HOL-1064. Thank you for joining me and see you next year or maybe on next SUSECON. Thank you very much. Bye bye.